Imagine creating a cutting-edge AI model that rivals industry giants like OpenAI, but at a fraction of the cost. DeepSeek R1 has done just that. Its release has upended assumptions about what's possible in AI development, offering enterprises and developers a glimpse into a future where innovation doesn't come with an astronomical price tag. But how did DeepSeek achieve this, and what does it mean for the future of AI? This is the story of how bold ideas and unconventional methods redefined what's possible in artificial intelligence. DeepSeek's key breakthrough lies in its decision to break from convention. Most AI models rely heavily on supervised fine-tuning, a method where curated datasets are used to teach step-by-step reasoning. DeepSeek, however, chose to forego supervised fine-tuning entirely during the initial stages of training. Instead, they relied solely on reinforcement learning, a method where the model learns by trial and error, rewarding itself for logical reasoning and correct answers. This bold move forced the model to develop independent reasoning capabilities, avoiding the rigidity of pre-designed datasets. While some supervised fine-tuning was later reintroduced for refinement, DeepSeek proved that reinforcement learning alone could unlock incredible performance gains. This decision represents a fundamental shift in how we think about AI training. DeepSeek's journey is a testament to the power of resourcefulness. Unlike AI giants like OpenAI or Google, which operate with hundreds of thousands of GPUs, DeepSeek trained its model with far fewer resources, 50,000 GPUs acquired before export restrictions. Their estimated budget of $5.58 million for training their base model is a drop in the bucket compared to the billions spent by their competitors. Even more impressive is their reliance on open-source technologies. By building on frameworks like Meta's Llama and PyTorch, DeepSeek demonstrated how open innovation and a leaner approach can compete with and even surpass proprietary models. It's a story of ingenuity triumphing over scale. One of the most fascinating aspects of DeepSeek R1's development was its so-called aha moment. During training, the model began allocating extra processing power to more complex problems, prioritizing tasks based on difficulty. This wasn't something it was programmed to do. It emerged naturally through reinforcement learning. Even more striking, the model articulated its reasoning in a human-like way, describing how it solved certain problems. For the researchers, this was a breakthrough moment that highlighted the untapped potential of reinforcement learning to create not only high-performing models, but also ones capable of explaining their decisions. DeepSeek's journey wasn't without hurdles. The intermediate version, R10, faced challenges like poor readability and inconsistent language use, often switching between Chinese and English. To address this, the team introduced a small amount of SFT using carefully selected chain-of-thought data to refine the model's outputs. Afterward, it underwent additional rounds of reinforcement learning and fine-tuning, resulting in the polished and highly capable DeepSeek R1. This iterative process demonstrates that innovation doesn't mean perfection from the start. It's about learning, adapting, and evolving through challenges. DeepSeek R1 is more than a technical achievement. It's a statement about the future of AI. By open-sourcing their model, DeepSeek is democratizing access to cutting-edge AI capabilities, enabling smaller organizations to compete with tech giants. Unlike many proprietary models, DeepSeek is also transparent, showing its chain of thought during decision-making. This allows developers to identify and fix errors, customize the model, and optimize performance for specific needs. This transparency has sparked debates, particularly with companies like OpenAI, which have kept their reasoning processes hidden. DeepSeek's success challenges this approach, proving that openness can be a competitive advantage. Despite its success, DeepSeek's rise hasn't been without controversy. Critics have pointed out potential biases in the model, influenced by Chinese regulations. While these biases are real, they are not unique to DeepSeek. Other models, including those from OpenAI, face similar challenges. Developers argue that these biases can be mitigated through fine-tuning, emphasizing that the benefits of open source outweigh the drawbacks. More broadly, DeepSeek's innovations are forcing enterprises to reconsider their reliance on proprietary AI providers. Why pay exorbitant fees for closed systems when open-source alternatives can deliver equal or even superior results? DeepSeek R1 represents a paradigm shift in AI development. It proves that cutting-edge performance doesn't require massive resources, just bold ideas and a willingness to rethink established practices. This democratization of AI could drive down costs, making advanced capabilities accessible to businesses and developers around the world. The ripple effects of this innovation will be felt across the industry. Proprietary AI providers will need to adapt or risk being left behind. For enterprises, the message is clear. The future of AI is open, efficient, and collaborative. DeepSeek R1 isn't just a technological breakthrough, it's a blueprint for the future of AI development. By challenging conventions, embracing transparency, and prioritizing efficiency, DeepSeek has shown what's possible when innovation takes precedence over scale. The question now is, how will the rest of the AI world respond? Will they embrace the open-source revolution, or double down on proprietary models? One thing is certain, the landscape of AI is changing, and those who adapt will shape the future. What do you think? Is DeepSeek the beginning of a new era in AI, or just a flash in the pan? Let's start the conversation.